Hello, everyone. Today we are going to continue on with our equality postulates. Yesterday we did the beginning with our reflexive, transitive, substitution, and lastly addition. Today we are starting with the subtraction postulate, which is very similar to the addition postulate other than we can subtract. So it says if equal quantities are subtracted from equal quantities, the differences are equal. So in my basic example here, when I have A equals B and C equals D, I can say that A minus C equals B minus D. And that would be the subtraction postulate. Now, when we're doing that with angles or segments, we need to take care to make sure we are doing larger minus smaller. So when we take a look at example 1 here, we have that DAC is equal to ECA. And those are equal actually because they're both straight lines, but we're given, so it doesn't matter. And we know angle 1 is equal to angle 2. And we want to prove that angle 3 is equal to angle 4. Measure of angle 3 is equal to measure of angle 4. So when we do our subtraction postulate, we need to do the measure of angle DAC minus the measure of angle 1. And the measure of angle ECA minus the measure of angle 2. And that is our subtraction postulate. And it's also important that you have two equations before you subtract. You can't subtract before you have two equations. Now, yesterday when I did the addition, I kind of skipped a step that we're going to be able to skip as we go forward, but I do want to point out that step to you. And the step that I was skipping is this step right here, where I say that the measure of angle DAC minus the measure of angle 1 is equal to the measure of angle 3. And then the measure of angle ECA minus the measure of angle 2 is equal to the measure of angle 4. And that step right there is really the angle subtraction postulate that we learned in Unit 1. And then our last step is finally substitution, which is where we can say the measure of angle 3 is equal to the measure of angle 4. Oh, I forgot my equal sign up here. Sorry about that. And then that's substitution. So I should have done those steps in yesterday's notes. So I'm going to go back up here to show you where I should have done that. And that's right here. So in between here, there's really should have been a step where I said the measure of ADF plus the measure of EDC is equal to the measure of angle ADC. And likewise, the measure of angle CBE plus the measure of angle ABF is equal to the measure of ABC. And that would have been our angle addition. And then this last part here would have been 4, which would have been substitution. And similarly up here, this really should have been 4 with substitution. And 3 should have been the AB plus BC equals AC, and DE plus EF equals DF. And that's segment addition. So sorry about that. I did want to take a minute and fix that. So sorry, I was thinking ahead because when we do it in the future, we're going to kind of shorten that all up. But for now, we should show all our steps. Okay, so now we're going to continue on here with step example 2. I'd like you to pause and give it a shot on your own and then come back and compare with mine. Okay, so welcome back. The first thing you'll notice I did in my solution is I kind of color coded. I did D, F in purple and B, E in green. And those are my givens. And that showed me that they both have EF. So remember, to add or subtract, I have to have two statements. And remember, we talked about that reflexive property that we thought seemed kind of silly, but here's where we're going to start to use it. I start out by saying EF is congruent to EF because of the reflexive property. That gives me two statements here in 1 and 2 that I can subtract. So then I use my subtraction property and I say DF minus EF equals BE minus EF. And then I use my segment subtraction where I say that BE minus EF equals FB and DF minus EF equals BE. And then substitution gives me BE is congruent to FB. Notice that I went from congruent to equal to do my subtraction and my segment substitution, and then I went back to congruence. So here is our next statement we're going to learn how to use, which is halves of equal quantities are equal. And right now, if I'm given that AB is congruent to DC, and I know that AF is half of AB, and I know EC is half of DC, that means that I can conclude that AF is congruent to EC because of our reason right there, which is halves of equal quantities are equal. And that becomes very useful when we're talking about bisectors or midpoints. So let's take a look here at example 1. We want to prove that R is congruent to S. So that's what we're looking for. We know that CA bisects DCB and DAB. So I'm going to stop right there and I'm going to think about, all right, what does that mean? Well, if CA bisects DCB, that means that angle S is equal to half of the measure of angle DCB, because angle bisector cuts an angle in half. And then the fact that CA also bisects angle DAB, that means angle R is equal to half of the measure of angle DAB. And it's for the same reason. So because it's the same reason, I can put it in the same step. Now, it's also given that DCB and DAB are congruent. So that means that angle S is congruent to angle R because halves of equal quantities are equal. Now, I do have to state that they're half of the thing first. Okay, and that's it for today's video. If you have any questions, please bring them to class. Tomorrow in class, we'll work on the practice problems.